Hi everyone, and welcome to Fundamentals of Statistics course. In this course, I will try to help you to understand the concept of the statistics. I will start from very beginning, assuming you don't know anything about statistics, and build your skills up step by step. So first of all, let's give the definition of statistics. What is statistics? Statistics is the science of conducting studies to collect, organize, summarize, analyze, and draw conclusions from data. Generally to be able to give better decisions, but we will talk about this later. So let's give some examples about statistics. Every 10 minutes, 2 people die in car accidents and 100 are injured. Drinking decaf coffee can increase the cholesterol level by 10%. The weight of the newborn baby is 3 kilograms, or 25% of people eating cereal for breakfast, or 80% of people doing this, or 20% of doing that. As I said, statistics is all about collecting data, analyze it, and draw a conclusion about it. So what I mean here, to be able to say those statistics, like every 10 minutes, 2 people die in car accidents, or so many of them are injured, first of all, you need to collect data. To collect the data, maybe you do surveys, maybe you just observe and count, maybe you perform some experiments and you measure something and record the data. And then once you have data, you need to organize it. Maybe you put them in a table, or you can make a graph to make it visibly more understandable. Then you analyze it. You look what data tells you. Maybe you find average and then try to interpret that data and draw a conclusion from it. So as I said, statistics is all about answering questions like, how much does newborn babies weight? Or is this new medication really increase the blood pressure of the patients? You must have a statistical question. So what is statistical question? Statistical question is the question that gives us variety of answers. Don't mix up statistical question with questions you ask to collect data on your survey or on your experiment. For example, if you want to find out how much do babies weigh when they're born, this is a statistical question, as it gives you variety of answers. You can't expect all babies to weigh the same. It will vary. So this is a statistical question. To find out this answer, you ask different question. You ask, for example, question to parents, the weight of their babies at birth. This is a question you ask to collect data to answer your statistical question. So let's assume we collect some data to answer this question, how much do babies weigh when they're born. And imagine that we found some data. This is randomly just created by myself, so it's not correct. So you can organize the data. You can put them in table, or maybe you can put them on a graph. For example, you can do dot plot. So let's do the dot plot on here to see what dot plot can gives us. So I'm going to round all the weights to the nearest kilogram. So when I look at this data, I can see I have 1.7, and that is the minimum, and I can see 5.1 for the maximum. So I'm going to start from 1, 2, 3, 4, 5. I really don't need 1, but let's do it like that. So 3 kilogram, I put 1 dot for 3. 1.7 can be round to 2. I'm going to put 1 for 2. 4.6 it can be round to 5. 3.2, it's 3. 2.7, it's 3. 2.4, we can say that it's 2, 5.1, it's 5, 3.3, another dot for 3, 1.9, it's 2, 3.3, 4.7, it's like 5, 2.9, 2.3, 3.2, 4, and 2.4. So, as you see, the peak here is at 3 kilogram. As you see, the peak is at 3 kilograms. So, maybe I can say most babies weigh about 3 kilograms by using this data. So, let's talk about another example. Imagine I would like to find out the average house prices in the UK. Imagine I would like to find out the house prices in the UK. And I went and asked 100 people living in South Bank, central London, how much they bought their houses for. And as a result, I found out the average house prices in the UK is £5 million. I found out average price of houses in the UK is £5 million. This is a joke. You know that is not really the case. But what I'm trying to tell you here, you can kind of present any information that is beneficial to you in statistic. If you want the average to be really, really high, you can go and ask people living in the South Bank, or if you want it to be really, really low, you can go somewhere which the house prices is cheaper. So lots of statistics you're hearing on TV or on internet, like 25% of people doing this and 80% of people doing that, 80% of men are like this. It's all made up. So what I'm trying to say here, when you read the conclusion about some statistical analysis, you need to be careful, as conclusion depends how the data was collected. Who did they ask? Did they ask the right question? How they analyze the data, as you can present any information the way you want to. So, for example, let's talk about another example. Imagine that we want to find about the average weight, maybe in the UK, maybe in one of the cities in the UK. So imagine you have 30 students taking statistic model, this statistic model. Imagine that we have like 30 students. And what I did, I measured those 30 students' weight and find the average weight. So I found the average weight as 67 kilogram. This is completely made up, okay? Question here. Can I draw a conclusion from this information? What conclusion can I draw from this information? Can I say 67 kilogram is the average weight of students studying at the Aston University? Can I say 67 kilogram is the average weight of students living in Birmingham? Can I say 67 kilogram is the average weight of people living in the UK or in the whole world? Is this small group of students can represent everyone in the UK? Of course not. How about if I ask 100 Aston students and find the average weight? Can this average represent the whole UK? Still not. How about if I ask 1 million, not just students, people living in the UK, their weight, and find average? Is this average represent the UK average weight? Or can I say it's the world average weight? It might be closer to the actual answer for UK, but still not represent the whole world. What I'm trying to say here is you need to be careful about how you take the data and what conclusion you draw from it. The question here is, how can I draw a conclusion by using the small sample because it is not possible to ask everybody to find out the answer of your question. And we're looking for to draw a conclusion by using the small sample, small group of people to talk about bigger sample. So if you take 30 students from Asda University and draw a conclusion from this and say average rate of people living in the UK is 67, this might not represent the reality. But there must be some sample size. Like, what if I weighed 1,000 people or 1 million people in the UK? Can I draw a conclusion from this and say the average rate of people living in Germany or anywhere in the Europe is 67 kilograms? It is getting a little bit better for maybe for UK if you ask 1,000 people or 1 million people, but still you need to consider the regional variation around the world if you're going to talk about Germany or Europe. So there are different average weight for people living, for example, in Asia or Africa versus UK. So taking 1,000 people or 1 million people from the UK may work for the UK, but may not say anything about, for example, Chinese people weight. But if you take people from different parts of the world, that might be more representative of worldwide average weight. But if you weight only students, even though you take many students from all over the world, which they are generally young and probably on their ideal weight, even though you collect 1 million data all over the world, this might not represent the reality. Yes? So let's summarize what we have talked here. It is very, very important in statistics to decide about your statistical question before you start collecting data to be able to answer your statistical question. You can't just collect data and then decide what you're going to do with that data. You can do it, but it's better if you decide your question, then you collect your data according to that. And also, it is very, very important how to collect data and draw a conclusion from that data.